Today, we're solving problem 11 and 12 from the Fall Amc 10B of 2021. Okay. A regular hexagon of side length 1 is inscribed in a circle. Each minor arc of the circle, determined by a side of the hexagon, is reflected over that side. What is the area of the region bounded by these 6 reflected arcs? Okay. So this might look really weird, but on the outside we have the circle and the hexagon inscribed in the circle, and we have these reflected arcs. Now we drew these 3 lines for more comprehension. This used to be, well, let's just use what we were given. It's a regular hexagon. That means one of these angle measures would be 120 degrees. But since when we construct a line like this going through these 2 vertices, they cut them in half, leaving this side be 60 degrees and this side be 60 degrees. Same things happen here. 60 degrees, 60 degrees. Well, if these 2 have to be 60, 60 plus 60 is 120 degrees. Therefore, this last angle has to be 60 degrees. Proving that these small triangles have the same side lengths. Okay, we are given that all of these side lengths are 1. This is an equilateral triangle, so all these other side lengths are 1 because we just proved it. 60 degrees, 60 degrees, and 60 degrees. Okay. Well, now we can just find the area of this equilateral triangle. The formula is √3 over 4 times the side length squared, but that's just times 1 times 1 squared. This is √3 over 4. Well, now that's the area of one of these equilateral triangles. There's 6 of them, so we have to multiply by 6. √3 over 4 times 6 is 3√3 over 2. That's the area of this whole section. Now, what does the problem ask? The problem asks what the area of the region bounded by the 6 reflected arcs is. Basically, we want the area with when you have this hexagon and then remove all the area the arcs take up. We have this space. Well, so what we want to do is we can actually think of a way to do this. The areas of these 2 arcs are the same because it's reflected over a line. It's still the same though. What we can do is we have the area of one of these triangles. We want to find the area of one of these quote-unquote pies, like one of these sections. And then we can subtract the area of the triangle to get the area of the arc. Well, okay, notice. We already know the specific requirements needed to know this area. Well, this pi right here, I'll call it, this is 1/6 of the total circle. So it'll be something over 6. Now the total area is pi times the radius squared. The radius is 1, so this is just times 1 squared. The area is pi over 6. Now, earlier, we stated that this is √3 over 4, the area of one of these arcs. Okay. If we subtract it, then we could possibly solve for it. Okay. Pi over 6 minus √3 over 4 gives us the arc area. Okay. That's pretty interesting. But now, notice, there are 6 of these arcs, so you have to multiply by 6. This gives us pi minus √3 over, this is pi minus 3√3 over 2 now. Okay. Well, now we have that. This is the area of one of these arcs. Now remember that these areas are the same. So we have this equilateral triangle area. We subtract No. Oh, no. This is the total area taken up by all of these arcs. We want to have the total area of the hexagon and then subtract the total area of the arcs. So 3 root 3 over 2 minus pi. Here, I'll remove the parentheses. Pi plus 3 root 3 over 2, because that's what you get when you remove the parentheses. This will give us our answer, 3 root 3 minus pi. And we are, in fact, done.